Let's take a look at the installation of the bracket. You can take a photo of the back and back before starting. For convenience, you can refer to it when configuring it later. It's okay to go up or down. Next we install it on the guide rail. Get stuck first. Then press into the other side. It's already installed. Then we will install the power plug. And motor connectors. Okay, the installation is complete. How to disassemble. I will use a tool to get out of this hole. Stuff it in. Pry it. You can take it off. And then we'll go over here. The first thing we see is I/0.0 interface. I/0.1 interface. These two interfaces can be used as input and output. For example, connect the limit switch or proximity switch. The voltage can be selected as 12V or 3.3V. 3.3 volts on the left, 12 volts on the right. When we leave the factory by default, all at 3.3V. If you need 12V, it can be connected to the 12-volt side. G for GND. 16 represents his GPIO port. Here I/0.0 and I/0.1 use 16 and 17 ports. And then, T0. T1 is an element of T2, located in the middle of two 5160 MOSFET arrays. If you want to monitor the temperature of the 5160, then we need to plug in the picket caps at the back of T1 and T2. Do not perform 5160 temperature monitoring if it is used for other purposes. We can remove the picket caps for T1 and T2. Then it can be used for other purposes. Next we look at the fan. The fan has two channels, then this fan can support a 4-wire fan. What if you use a 4-wire fan? You need to place the picking cap at the top end. If second and third wire fans are used, the jumper cap needs to be placed at the lower end. When it leaves the factory, we are fan set to second and third wire. These two jumpers are used to select the fan voltage. What about its voltage? 5V and 12V optional. What if the fan uses 2 wires? Default only use pins 1 and 2 of the interface. If it is a 4-wire fan, we need to use all 4 pins. If it is a 3-wire fan, it is the 3 pins 1, 2, and 3. TACH stands for speed feedback. PWM represents the control signal. Jumper at this position, when we use CAN. This jumper cap must be plugged in. However, if you use CAN FD, we need to pull this cable cap out. These 5 pins are the debugging interface of the RP2040. If the 2 interfaces on the right are shorted, then we can operate without 24V/48V power supply. Powering the chip since USB. At this time, you can use USB. Directly burn the RP2040. And what about the one below? Is an enable interface for a 120 ohms termination resistor. If we are looking at multiple StrideMax connections to the CAN bus, then we just need to plug one of them into the jumper cap. Because the CAN bus protocol stipulates that only the first and last devices have 120 ohms resistors. When it leaves the factory, by default, each one is plugged in with a PIC wire cap. So now we're going to look at the buttons. This is the Butzel button. This is the reset button. When we want to burn, we need to hold down Butzel first. Then press the reset button again. We want to keep it at 0.5 seconds or more, and make sure you have pressed it. Sometimes when operating, maybe it means the time is too short, or didn't press. Then we release Butzel. Then you can enter boot mode at this time. Let's take a look at LED lights. There are 6 LEDs on the StrideMax. They're the voltages. VIN VM 12V, 5V 3.3V. There is a fuse between VIN and VM. The 2 indicator lights turn on at the same time. That means there is no problem with the fuse. If one of them lights up, then there's a problem with the fuse. 12V, 5V, 3.3V are the 3 voltages on the board. If anyone is not lit, it means there is a fault. Status indicator can be used for bootloader instructions. Factory default does not use bootloader. To use the bootloader, refer to the usage of Catapult. It can also be found in Klipper. To set a status indicator, used to indicate a working state of the board is also possible. Next, let's take a look at how to burn and configure StrideMax Dual FD. First we open the warehouse address of StrideMax Dual FD. In this warehouse, there are schematic diagrams and PCBs. When configuring, we can refer to the schematic diagram or the back of the board. Via bitmap, we can find the exact location of each component. 2D and 3D diagrams are convenient. You use it when modeling. The board also supports RRF firmware. RRF firmware configuration and firmware. Here it is. Let's take a look today, mainly at Klipper. How to burn and configure in SBC CM68/Raspberry Pi. First, we log into the background of the SBC via SSH. Let's take a look at our equipment. Before burning, let's first. This board goes into boot mode. Then we'll check it out with lsuzb. Does it go into gut mode? And here we can see that it's gone into gut mode. Let's compile the firmware for it. First enter the Klipper directory. Configure the firmware. Select 2040. Others keep the default. It communicates by USB. Keep default. OK, then use. Wait for compilation and burning to complete. Something went wrong here. Let's see what went wrong. I made a mistake here. Is there any mistake? It can't be burned in. OK, this interface is fine. We'll burn another one. We use the same command to treat burning. Then we get his ID through the command. You can see that we have two 2040 IDs. We don't know the correspondence. Let's get rid of one first. And let's see. There is an ID at this time ending with F2B. OK, F2B, it's the one above. This is the one below. Let's record these two IDs. Then go to our web page configuration. Configure R separately here. The IDs corresponding to X and Y. After the configuration is completed, we click Save and Restart. This part of the content is copied directly from the GitHub repository. Put this part of the content can be copied. Paste. That's it. Just change these two IDs. So I've copied it here. I will stop copying. Also make sure there is no problem with the configuration of SPI here. SCLK is PIO2. MOSI is PIO3. MISO is PIO4. In our early engineering prototypes, the two IOs are switched. They exchanged. But in the official release version, there is no such problem. After we configure, direct restart. If all goes well, it starts successfully. We go to the home page. Before resetting, you may need to adjust it. The corresponding relationship between your motor position and the direction of rotation. Make sure there's a one-to-one correspondence. And make sure your two StrideMax also correspond to your XY. Then let's reset it and take a look. This is an all-wheel drive testing device we built. It can be reset normally. After reset, You can perform normal printing.